This submission presents a high-performance n-body simulation accelerator, and this video will focus on key modifications to the build flow that were necessary for this project. We were faced with the issue that our compute kernel required reading 3 vectors in a pipeline fashion representing the x, y, and z dimensions for the simulation, whereas the Axie master interface only allows data widths that are a power of 2. Implementing this highly irregular conversion turned out to not be feasible in HLS, so we had to use a Vivado IP instead. The project is configured and built using CMake, which is responsible for building both the software and the hardware part of the project. A CMake target runs a tickle script that sets up the correct parameters and runs high-level synthesis, the output of which we will need later to package as an RTL kernel. We then run a project setup target, which executes a tickle script using the kernel wizard from Vitis to create an RTL project with the appropriate parameters that is then exported for use in subsequent scripts. We use another tickle script to import the source Verilog and floating point IPs generated by our HLS project, then create the memory width converter IPs that we wish to inject into the HLS project. To run the kernel in simulation, the HLS project defines software implementations of the converters, which is used instead of the Vivado IPs when run in simulation mode. Once all the Verilog and IPs have been imported into the project is packaged as a .xo file to be built by the standard Vitis toolflow using yet another tickle script. Finally, we can build the packaged kernel with the standard synthesis, place, and route flow provided by the Vitis link command. Apart from the specific IPs needed by this project, this full CMake-based flow can be used by any HLS project that requires Vivado IPs to implement critical operations efficiently. With these modifications, we managed to build our kernel and run our n-body simulation at almost 300 gigaflops of performance on a HLS 2050 accelerator. Thank you for your consideration.